So here we are in Chapter 7, Section 2, problem number 7. City planners wish to estimate the mean lifetime of the most commonly planted trees in urban settings. A sample of 16 recently felled trees yielded mean age of 32.7 years with standard deviation 3.1 years. Assuming the lifetimes of all such trees are normally distributed, construct a 99.8% confidence interval for the mean lifetime of all such trees. So our confidence interval is a high one, 99.8% confident. Let's see, we want that on the mean. We've got a sample size of 16, so n equals 16. We have our x bar of 32.7 and sample standard deviation of 3.1. So we know we've got a normally distributed, or we're assuming normally distributed, on our tree lifetime. So to construct the confidence interval, as usual with confidence intervals, we need the alpha level. So the alpha is going to be 0.2%, or that's a percent, not a 6, or let's see, 0.002, and we're always needing the alpha over 2, right? So that's going to be 0.001. And let's see, our sample size is less than 30, so we're in small sample size, which you would guess because we're in section 2, right? Which is talking about small sample size. And so to come up with our confidence interval, our 99.8% confidence interval, we have our x bar plus or minus. Since we're at a small sample size, we're going to be using the t distribution of alpha over 2. And again, we're going to have our sample standard deviation divided by the square root of our sample size. And the other thing to remember is degrees of freedom equals n minus 1 is going to be 14. Nope, that's not 14. I was talking about 14 in an example in the book here a moment ago, so that's where I was. So this is going to be 16 minus 1 is 15 degrees of freedom. Okay, so our x bar is 32.7 years, plus or minus t of alpha over 2. And we've got s, our standard deviation of our sample, 3.1, square root of our sample size. So we want t of 0.001 with degrees of freedom 15. If we go look up in the table, look for our column of t being 0.001 and go down to the row that's headed 15, we see that that equals 3.733. So that's going to go in here. So we're going to have 32.7 plus or minus, that's a plus sign, 2.9. So our interval is 29.8 to 35.6. So there is our 99.8% confidence interval for the mean lifetime of all such trees. So we know that the mean of all such trees is going to be between 29.8 and 35.6 with 99.8% confidence based on this sample.